They are, and please welcome, William Lark and Carlos Fernandez Isoer from Hiriko project.
Hola. Buenas tardes. Perdona, mi castellano is mal, so yo hablo en inglés, and Carlos will speak in Spanish if that's okay. Thank you for having us, and thank you for being accommodating to the schedule change. I know it's a little bit confusing, but we have a very exciting project that's coming up around the corner pretty soon, and we're happy to share this with you, called Hiriko. And what we're doing with Hiriko is looking at a new way to offer mobility services. What we're going to look at today is a little bit about the vehicle, but keep in mind that it's a larger vision for mobility in urban areas. So what's the challenge? Really rethinking the concept of sustainable urban mobility. We have a lot of trends that are changing, the way we think about cities, the way we move around, and the current solution is not sustainable. As gas prices continue to increase, this becomes more of the norm in many cities, and this problem is not going to go down anytime soon. I think in 2008 we just passed a threshold where we have more people living in cities, and this trend is projected to continue. So we're going to have more of these issues. If we look at some of the numbers that are alarming, 80% of the urban trips are usually made by one person. So you have a large SUV or even just a two-passenger vehicle with one person in it. And most of these, as I said, most of the population is moving to the urban areas, and this trend will continue to grow. Apologize, it seems to be a typo right there, but if we look at some of the very dense urban cities, for example, in Manhattan and New York, during peak hours, up to 40% of the gasoline can be wasted just looking for a parking space. So that means you've left your home, your apartment, or wherever you were, got to the area where you need to conduct your business or purchase goods, and you're wasting about 40% of the gasoline just circling around and around just looking for a parking space. So these solutions are not very intelligent for some of the needs in cities. And particularly in Spain, oil consumption, about 36% of it is used just for cars. Anything I touched on there? No problem. So what we're looking at is a new way to offer something that provides services in an urban area. And what we're looking at here is a concept that we developed at MIT, and we're working with Hiriko now to develop, which is called Hiriko. It's a two-passenger electric vehicle, uses robot wheels, so each wheel can operate independently, so the vehicle can spin. You can design the interior differently. No longer do you have a central engine with mechanical couplings out to the ends, but localized robotic wheels. Because you have this freedom, you can do things like drastically reduce the footprint of the car. So the car is small when it needs to be, when it's parked, and it's large and has a better wheelbase when it's moving around. And if you notice too, it's a front entry and exit vehicle. So we imagine these vehicles, you run them around. When you're done, you pull up into the sidewalk and step right out of the front of the vehicle. This image right here shows a typical scenario of how you would use the Hiriko vehicle. Like I said, this is about a system of mobility. So just as we have growing Zipcar, VLib, BSing, all these different shareable systems, we're doing this with electric vehicles so that as you're being a member of this, you rent a vehicle from the stack, run your errands, and return it to another conveniently located station. One of the enablers for this vehicle is what we call robot wheels. So if you noticed in the video, all the wheels turned independently. And the way we're able to do that is by centralizing the drive motor, the suspension, and the steering all in a modular unit that snaps onto a basic chassis. And we take this even a little bit further, this modular approach of how we build the vehicle. So vehicles are very sophisticated, integrated pieces of engineering. But what we're doing is opening up the platform some so that we can rethink how you design the interior, rethink how you use the vehicle, and really allow for a different type of model that not only affects the features or the performance of the car, but even the manufacturing. It really changes how you build the vehicle itself. So right now we have the vehicle broken up into these 7 larger categories of modules, being the robot wheels, the glazing, the structure of the vehicle, the storage, the rear compartment, interior cabin, the batteries and electronics, the batteries, and the electronics module. And as Carlos will talk about a little bit more, each of these fit into a different type of business model where we have typically what you see is suppliers that give parts for the vehicle, now providing core components of the vehicle that allow different assembly modules. So you start to treat the vehicle a little more like a computer. The heart of the vehicle is located in the robot wheels, just like a external hard drive or a hard drive that you have in your PC. It's something that you can switch, upgrade, or service over time. And a number of these different suppliers are local in the Basque region and in Spain that are supplying the components for this vehicle. So it's a different type of model of than you would get from a typical OEM. As you saw from the video, with the wheels turning, the vehicle can spin, it can slide sideways, do all these different movements. And although this adds a level of complexity to the vehicle, I'd like to take a second just to think a little bit further about what this can do for your cities. It's not just about getting where you need to be, but it's about how you use energy and how you use space. I'm sorry. So the previous image shows what we call omnidirectional movement. So this vehicle kind of moves like we do as people. We walk forward, we go around. If we have to dodge something, we turn to the side, we step to the side. We do all these types of movements that allow us to continue moving forward. And this also says something about safety, where you can minimize the amount of times that you need to put the vehicle in reverse or maneuver out of a spot. This level of maneuverability is also very important in very tight cities. I've been out here for a year in Europe now, and I've already noticed, I'm from the US, and our roads tend to be a little wider and a little easier to navigate. But when you start to see some of these small cities, having a high level of maneuverability is very important. In addition, you can start to think about user interaction and how you engage with the vehicle. As you saw from the video, it's a front entry and exit vehicle. So these vehicles park nose into the curb. As the door opens, you walk right out to the front, you walk right onto the sidewalk and run your errands or whatever you're doing. Not only are we able to get cars closer together to save space in the city, but this also says something about safety, especially in the cities. In Boston, we have a lot of bikers, and I'm sure it's the same here. You don't need to swing your door open, which creates a hazard for the cyclist, but also requires the person to walk out into traffic to get to the sidewalk. This allows you to get right off onto the curb, which can also be helpful for elderly or people with any types of disabilities, because the folding of the vehicle allows an easier exit. And then I think the big thing, which adds some complexity to the vehicle, but when you think about this from a larger perspective of a systemic solution for mobility, the space of the vehicle is very important. So the vehicle starts off at about the size of a smart car and can reduce its footprint up to 40% to drastically reduce the space that it's used while it's parking. This, in combination with the nose-in parking, allows us to get up to a 3-to-1 ratio for a normal car. So we can fit a lot more cars in with parallel parking, which is very important for this type of shared system. But when we think about this on a larger scale, this can expand even more. This may help us with sidewalk parking, but it's even a bigger deal when you start to think about structures and parking lots. The one on the bottom is very typical of, well, you have a parking garage, whether it's here or in the US or anywhere in Europe. But we can get a lot more vehicles in the space, or we can even just reduce the size of the space so we can rededicate it to other green areas or other living spaces. In Cambridge and in Boston, about at least 1/3 of the square footage is just dedicated to vehicles moving and parking. So if we can reduce that and repurpose the land, we feel it's a winning solution for urban areas. And then if you think about this a little bit further, in a shared model where it doesn't matter which vehicle you use, you just take one off the front of the stack and return it later, we can rethink how we use all the space. So now you can really stack the vehicles in and get more vehicles in the same amount of space that you would use a regular one. The big thing with parking lots, and if there are any urban planners or architects in here, you know that a lot of space is dedicated to parking lots just to maneuver the vehicle. I don't know if I have the mouse here. Yeah, a lot of the space that could be used for parking is just so the vehicles can move in and out. But if we do something like this where we can stack them in, we can get more in. And then the cost savings are such that you could possibly, as a landowner or an apartment owner, you could offer free vehicles to your tenants for the price that you would save just to build the parking lot to accommodate all those vehicles. And these are just some of the montages and ideas that we can look at. The big thing here is being able to offer mobility for what we call the last mile. Public transportation is great because it serves the masses and is very efficient up to a certain point. And owned vehicles are great because you have the level of convenience to get wherever you want when you need. But the issue we want to solve is this multimodal last mile. So when you take the train, the subway, or whatever, can you take one of these cars off the stack and get to exactly where you need to be? So you'd imagine these be parked at subways, airport stations, different types of venues for entertainment. So these are some of the ideas that feed into this. And given the time is very short, if there are any other questions about this vision of mobility, the Reinventing the Automobile kind of covers a lot of these issues. Now that's the big idea of what Hiriko is looking into with new mobility. There are a number of technology challenges here that I'll pass over to Carlos to take over.
Bien, gracias, Will. Bueno, yo os voy a contar dos cosas. Por una parte, los retos desde el punto de vista del diseño y el desarrollo del producto, pero por otro lado también la historia de cómo esto, que nace en el MIT, acaba en Vitoria-Gasteiz. Hace año y medio que un grupo de personas de aquí del País Vasco fuimos al MIT, vimos un proyecto en el cual estaban trabajando, vimos un prototipo de coche a escala a la mitad, vimos una plataforma con unas roborruedas, vimos toda una forma diferente quizás de concebir la movilidad en la ciudad. Y creo que ese es un poco el elemento clave que está detrás de todo, ¿no? De todo lo que es el diseño y el haber llegado a este vehículo no parte de un diseño de ingeniería, de vamos a hacer un coche muy bonito o vamos a hacer un coche de dos plazas, que es lo que se puede plantear la industria del automóvil tradicional, sino parte de un grupo de arquitectos, no de ingenieros, que piensan en cómo debería de ser la movilidad del futuro en las ciudades. Y a partir de empezar a pensar cómo tiene que ser la movilidad del futuro en las ciudades y cómo podemos garantizar una movilidad sostenible, económica, medioambiental y también en este caso pues, tecnológicamente, surge la idea de crear un producto, en este caso es una utility, para conseguir esa movilidad, para poderte mover en la ciudad punto a punto de una forma eficiente y que además permita pues, que todo el mundo use el vehículo en un pago por uso. Algo similar a lo de las bicicletas, pero un poquito distinto. Todo lo que es el modelo que se está desarrollando, y este es uno de los grandes retos tecnológicos, más allá del propio coche, es conseguir que tú puedas coger el coche en un sitio, dejarlo donde quieras y que los coches en la ciudad estén redistribuidos de forma adecuada. Es un problema de diseño, en este caso, de un sistema de gestión de la movilidad y de un sistema de gestión social, en cierta medida, de cómo la gente se va a desplazar de un sitio a otro. Entonces, ese es el gran reto. En estos momentos, con las bicicletas, que también tenemos aquí en Bilbao, que se pueden alquilar y compartir, hay un gran problema y es que todas las noches van unos camiones, las recogen porque la gente las deja en otros sitios y las tiene que volver a reposicionar en los parkings para que a la mañana vuelva a haber bicicletas en los parkings. Eso con coches parece bastante difícil de hacer. Entonces, lo que se ha diseñado y se ha desarrollado es un sistema de movilidad bajo demanda con incentivos